And then share my desktop. Okay. All right, just verifying again that you all can see on your end on Skype.
Yes, all good.
All right. So we're going to do what's labeled, I think, as week 4. Oh, I had it up, but I rebooted. So I'll start PowerPoint again. So remember, we're just 1 week behind. I guess we should look at the schedule real quick to see where we are, since we are 1 week behind, if that'll affect the midterm exam. Let me look at the schedule because there was a question about that. Okay. So yeah, this will be fine. If we keep to this schedule, then what we'll do is we'll still have the midterm the week before spring break. That's good because it is possible. It's not for sure, but it is possible. I planned for if I was gonna have to miss a week, it'd be that week. So, let's keep to the current schedule, and we probably won't cover this material, and so therefore it won't be on the exam. So we'll cover up this. Well, we'll still cover chapter 11. We're a week behind right now. And so we're doing this right now, and it's February 19th because we took a little bit longer in here, which is fine. So we'll be okay. But that material probably won't be. This material probably won't be on test 1 unless we can make it up and do these two together.
We'll discuss like the test a little bit more as it kind of like.
We'll have a review session before the test.
And like the format, how it goes.
Exactly. Yep. All right. So that's where we are. So we still have, I guess.
We have another project in here, like a paper. You said something about that? Did you write anything in here?
Yeah, and we can talk about that too.
Okay, and is that due?
That's due towards the end of the semester.
Okay.
Yeah.
All right.
Okay. All right. So, quick review of what we did last time, which was talk about the. I'm ahead in my book here, but I'll just go back to the syllabus to do that. So what we talked about last week was probability basics and distributions. We finished up discrete. We talked about the Poisson distribution, and then we moved into continuous distributions. And that leads us into what we're going to talk about today, because with those numbers that we calculated last week, we were really looking at we hadn't really discussed the difference between a population and a sample yet, and so we were assuming that our past history, most of the examples we're talking about like past history of climate data, was really the population. In other words, it was the entire set of data that we're looking at. Well, when we're trying to come up with these estimates of what the value might be in the future, or based on the past record, what they might be in the future, sometimes we don't, or it doesn't always have to be with time, it could be with space. So space or time, we're trying to estimate something. We may not have the luxury of having the entire past record or the entire other place record. That entire record is referred to as the population. Okay? In other words, every possible value that we could have about something, we have it. If we wanted to talk about like the census, the entire set record of the census is the population, right? So I think they ask everybody, they count everybody. I think one of the questions they ask everybody is how many like, actually I don't even know all the questions that they ask everybody, but anyway, they ask a lot of questions, but not from everybody. And so those set of questions that they only ask a certain number of people, you could call that a sample. A sample is a subset of the population. And today, our goal is to learn about coming up with an estimate of what a true population value is based on having a sample of that population value. And we're gonna categorize that into three different things. Coming up with an estimation, coming up with an estimate of the mean population value. In other words, the average population value. Now, sometimes, okay, well, one categorical variable that they ask on the census is gender, right? Male, female, and so sometimes that's a categorical variable, right? There's not a number. In other words, nobody puts down 1.7 when they ask whether you're male or female. Well, they can't. This is just male or female bubble. All right. So sometimes instead of the mean, in those cases, we're interested in the proportion of a particular categorical variable. So today we're going to talk about estimating. If I take a sample and I want and I'm looking at a numerical variable, then I could then sometimes I might want to know, does this sample represent the population, and with what degree of confidence do I have that this sample mean represents the true population mean? One thing. Or if it's a proportion, in other words, if I get 50% male, with what degree confidence can I say that the true population proportion is 50%? Or another application that I just actually had to do this week, somebody sent me a paper that we were working on. We're looking at accuracies, map accuracy. And one way to assess map accuracy is to come up with, take some samples, to like go in and find some, like randomly sample, find some areas, and then figure out for sure if that is really the category you say it is. Okay. So that's another way to look at it, because what you're getting is not the actual amount of error in the map. You just know the amount of error in your sample. So how much error is there in the entire map? That is what we're going to talk about today. And then one thing that you also could look at, we're going to talk about three different things that we're going to try to estimate. The mean, which is actually the easiest. The population, which also isn't that hard. I mean, sorry, the proportion, if we're talking about a different type of number. Those are really similar. And then the total. Okay. Now, there's some really neat statistical concepts that make it so that we can estimate these fairly well. But the first thing is that in order to use these statistical methods, we have to talk about sampling first. Because if we don't sample correctly, then our assumptions using the math won't work. And one thing I want to say is, this is probably, this is probably one of the more, this is probably one of the, like, you'll have to do a little bit of math when you do the exercises for this. Like, so if you need some help and you want me to break it down a little bit more, then then I can definitely help in there. We'll probably start talking about it. As we go into the future, we'll rely a little bit more on the software to apply this stuff. But it's a good exercise to understand why it works by doing some simple mathematical examples. So the math examples may seem like you're punching in a lot of numbers, but they're not a whole lot of numbers, and then they kind of help you get the idea of where you're going. I'll try to go over a few of those. All right, but like I said, let's start with talking about sampling, because the important thing is here to learn about what good sampling technique is, because the numbers in terms of being able to estimate these values don't work if we don't have good sampling technique, right? So we're going to talk about several of these things. Some of them, I mean, they might seem kind of obvious. I'm still going to go over a few of those. So the advantage of sampling, sampling error, sampling procedure. We could sum up the advantages of sampling as in it costs a whole lot less, and sometimes it's actually impossible to know. Like, it's impossible to know in some cases what the total population value is. In other words, we don't either have enough resources, we don't have enough time to figure out the population value. So to say sampling is necessary for many geographic research problems may be an understatement. To find the population value may be simply too big for 100% contact. We can't. Sometimes we're interested, like when we make a map, we're interested in finding out how accurate it is. Well, if we found out truly, let's say it was a map, if we went to every single location and found out what the error was, we might as well have just used that technique to make the map in the first place, right? Like, it would be silly to like use a technique, find out if it works, and then go to every single. We can't go to every single location all the time. So sampling is an efficient and cost-effective method for collecting information. I did that already. Oh.